So welcome everyone. I see a few people joining us. I'm going to give this 1 minute for other attendees to join, and then we'll kick off. All right, we'll give it another 30 seconds. All right, so let's go. Good morning, good evening, good afternoon, everybody. So welcome to our webinar, A Revolutionary Way to Measure Noise and Take Effective Measures for Your City and Enterprise. We're very happy to have you here today. So what are we going to do today? In this webinar, we're going to present to you noise-related matters on a city and an industry level. What can be done to better identify noise, and which solutions can be proposed to take action to the benefit of citizens and workers. So I would like to introduce to you a very interesting lineup of speakers today. I'd like to first welcome Theo Benjert. Theo is a senior noise expert at the urban development for the municipality of Rotterdam, and he's also the co-chair of the working group Noise at Eurocities. Theo is going to give us a broad understanding of the impact of noise and the actions that are being taken at the European level. Next up is Didier Hilal. Didier is co-founder and director of strategic accounts at Orbiwise for the EMEA and the APAC regions. And he'll reveal to us an IoT-driven alternative to traditional sound level meters that can give us noise information in real time and at low cost. We'll continue with two real-life examples of IoT deployments that have been done in the cities of Carouge in Switzerland, as well as Geneva, and at Chevron's refinery in California. To that extent, we have invited here Paul Royo, who is head of sector in charge of monitoring air pollution and traffic noise at SABRA, the Air and Noise Quality Service before the Republic and Canton of Geneva, which is a mouthful. Welcome, Paul. And we have Sam Bisram, who is a manager in IPS, Technology Innovation at Chevron, overseeing all the aspects of the El Segundo refinery in California in the US. And Sam will be talking to industrial solutions here. Welcome, Sam. So if you have any questions for our speakers throughout the webinar, we're going to have a Q&A session at the end of the presentation. So you can enter your questions in the Q&A section, which is to be found either on top or on the bottom of your screen. So I would like to invite now Theo to the floor for your presentation. Take it away.
Okay, hello everybody. As said, I'm Theo Benjert and I work as a noise expert for the municipality of Rotterdam, and I'm also a co-chair of the working group Noise from Eurocities. The impact of noise on health is often underestimated, and noise is a hidden killer. In case of a traffic accident, you see the consequences immediately. For noise, this is a stealthy process from annoyance to stress to symptoms of disease, and finally resulting in death. For Europe, it has been calculated that noise pollution cost 1 million healthy years of life lost each year. Next slide. In this slide, you see the numbers of Europeans affected by harmful effects due to noise. 150 million Europeans, nearly 1 of every 3 Europeans are affected in some way by noise. More than 70% of the Europeans living in cities. So cities can play an important role in solving the noise problems. Next slide. In major cities, residents and visitors create a lot of road traffic movements, and it is therefore not surprising that road traffic noise is by far the biggest annoyance source. 80% of all the Europeans who are affected by harmful effects due to noise are related to road traffic noise. From the European Commission, there is a lot of attention for noise generated by road traffic. The next slide. But Europe is working on it. First of all, I would mention the Eurocities statement. A network of major European cities is constantly working on the noise problems in cities. Together with all air pollution experts and mobility experts, a statement has been made by this network. This statement was shared with the Environment Department of the European Commission and supported the initiative to put noise pollution on the European agenda. And noise pollution was then given a place in the European Action Plan toward zero pollution for air, water and soil. And this action plan was launched this year. And the third item I want to speak about is the Phenomena project. This project was funded by the European Commission. And the objective of this study was to support the European Commission in defining the potential measures capable of delivering significant reductions of more than 20% of field burden due to environmental noise by 2030. And to assess how relevant noise-related legislation could enhance the implementation of measures, while considering the constraint and the specific features of each transport mode. The result is a main report of more than 300 pages, I think, and it was also launched this year. Next slide. As I said, I'm co-chair of a network of Eurocities, and that is a network of major European cities, and when we work on a statement. And this network is called Eurocities, and their office is located in Brussels. This network is a platform for sharing and knowledge and ideas, and try to make cross connections between the different teams. The teams where Eurocities is working on are economy, social affairs, culture, environment, mobility, and knowledge society. In the picture is shown as a metro network with connections between the different topics. Noise is one of the relevant topics from environment. Collaboration for noise is arranged in a working group, and Eurocities lobbies at the European Commission and provides advice to the Commission staff. Next slide. Here you see the Eurocities statement. A policy that makes a real difference to health is to set the target for the noise reduction. And the Eurocity statement includes a target of 3 dB reduction for road traffic noise by 2032. And this target will be resulting in 26% less high annoyed people and 32 less high sleep disturbance. Other measures cities can take care are reduce the permitted driving speed, include the noise aspect in mobility plans, stimulate the use of quiet tires and the application of quiet road service. The next slide. Eurocity contacts with the Commission staff and resulted in a noise being included in the Commission Zero Emission Action Plan. At first, the action plan was about air, water, and soil. After the air quality target, noise comes in second place, with reduced by 30% the share of people chronically disturbed by transport noise. The Commission was indicated that it will focus on measures at the source, not in the transmission or at the receiver. The Commission will focus on better tackling noise and at the source, in particular by ensuring appropriate implementation by improving the EU noise framework. And they are also proposed to integrate noise into mobility plans, just as proposed in the statement I just told about. And furthermore, they indicate that money is available for investment that reduce pollution. Next slide. The Venema project. The first part of this reference work on noise legislation in Europe, the study found that noise as a policy issue lies at the crossroads of different policy areas, such as environment, health, transport, and urban planning, etc. The report also includes an overview of 300 action plans. The aim of the review was to identify what noise abatement measures are planned and implemented in the member states. The project analyzes the health effects of different measures and how the benefits were related to the cost. And they looked at all the transport modes. For road transport, the measures they looked on were, for example, quieter road service, quieter tires, quieter vehicles, electric vehicles, and so on. For railway, smooth tracks, smooth wheels, quiet vehicles, quiet tracks, barriers, aircraft, improved flight profiles, precision, night curfews, phase out of noisier aircraft, and so on. A lot of different measures they looked at. What the Venema project also did was analyze the effect of different combinations of measures. For road, the best combination was quiet roads, quieter tires, and specific lower vehicle sound limits. And it gives almost a burden reduction in 2030 from around maybe 20%. And the cost-benefit ratio was from 1 to 5. And she did this analysis also for rail and aircraft noise. Also, I think, yeah, the next slide. So this is my last slide, and a number of action plans have not resulted in a significant reduction in number of people affected with noise. The first action plan was from 2008, I think, and we're now in 2021. And yeah, we see at most a stabilization. In the major cities, there is a great demand for new dwellings. and more inhabitants create more traffic movements and also more noise. And if we want to achieve a 30% reduction of people affected by transport noise, the city needs help, support in making the noise situation visible, and advice for the most effective and possible measures, and visualization of the effects of these measures. So, city needs affordable and smart solutions. And that was my contribution.
Thank you, Theo. It was a very interesting introduction to the issue at large, and especially in a European framework. So we're going to move on to Didier Lal, who works for Orbiwise, who is going to introduce us to a solution that may very well fit these issues. Didier.
Thank you, Anne, and thank you, Theo, for this insight on noise pollution threat that we are all exposed to. So, yes, I would really like now to introduce this affordable and smart solution, a really new way to measure environmental noise, an easy and accurate way. Next slide, please. I will first introduce Orbiwise. So we are a company founded in 2014 from former fellows of the telecom industry. And we are headquartered in Geneva, 40 collaborators, customers all over the world. And we are a leading supplier of noise management solutions based on low power wide area radio. So basically Internet of Things based on an inexpensive infrastructure that is deployed over cities or industrial campuses. So we have, for this noise management solution, 3 segments of customers, I mean cities, enterprises, and also experts and researchers. Next slide, please. So what usually our customers are wishing to do is to find a fast and cost-effective way to take noise mitigation measures, because they care about the quality of life of citizens or employees, and because also they have to comply with regulations. And what they need for doing that is actually a solution that would be real-time, that would give them actionable data in a cost-effective and easily maintainable way. Unfortunately, as Theo was exposing, what they get today is based on a traditional way to measure the environmental noise. It's based on expensive sound level meters that are very accurate, but that you are moving inside the area from one location to the other to make the measurements sequentially in these places and get the data into a map. So next slide, please. So it's a very inconvenient way to measure the noise, actually, because these bulky instruments are actually consuming a lot of resources to be manipulated and moved around the city. They are also very expensive. You can pay 8,000 € for a certified sound level meter. And unfortunately, the very high accuracy of this certified device is completely lost in the way of doing the measurements. Actually, the measurements are done sequentially in different places, most of the time over a period of months or even years. And they are combined with models of traffic, like counting the cars, models of the city, like 3D models of the buildings. And in the end, we get probabilistic results instead of really real-time measurements. So these maps are produced with a tedious, expensive, and time-consuming manner. Next slide, please. So is there a way, an easier, faster way to foster results? This is a question that we have answered together with our customers. So on the next slide, we came to this idea together with our customers of using the technology that we were knowing into the smartphone industry to create high performance, low cost wireless sensors that would continuously measure and compute the equivalent noise level in dBA, and periodically transmit these statistics reports. So you see that the device is quite easy to install on an infrastructure, usually a lamppost or a pole. It's small, the size of a can. It's light, roughly 300 grams with a battery. And despite this very, I would say, convenient object characteristics, we still can do very accurate measurements. So we are within 0.5 dB from a class 1 certified sound level meter. So it's very, very accurate measurements. And on top of that, this battery operated device can last for 1 year in the field without maintenance. So we can use it with this LoRaWAN protocol, radio protocol, and we can use, I mean, which is available almost all over in any country of this of the world. On the next slide, I give you a view of how to use this solution. So the sensors that are installed in the city or the industrial campus, they are actually measuring the noise, creating the statistics locally, and then sending the statistics to the wireless infrastructure. And this wireless infrastructure are storing the data into databases that will serve analytics and dashboard servers to provide, you know, the visualization and also the KPIs that are needed to manage the noise. Of course, these data are exposed also to any type of digital transformation tool in the city or in the industry. So thanks to these devices, to these sensors, to these noise measurement sensors, we can monitor the road traffic. We can assess the corrective measures very quickly. We can immediately know if a road work is impacting in a street, is impacting the streets around. And we can also support the urban planning thanks to these devices. We can evaluate the silent districts where real estate value is likely to go up when there is less noise. We can also check the workers' environment, either in the factory or in the office. And it can be also simply for restaurants and pubs to self-assess if they are going above or not the level of noise that is authorized in the street. Next slide. This solution is actually bringing a lot of benefits. So the first one is that it's an easy to install solution and also easy to maintain thanks to the long battery lifetime. And it makes it then in the end very cost effective. And most of all, you have like a real-time measurement and a permanent measurement of the noise, which really allow to personalize all the settings of your way to manage the noise. So should it be the time for which you want the statistics to be calculated, or should it be the noise level limits to trigger an alert on one sensor or a combination of sensors? And thanks to all this data, we actually can, we see that there are a lot of new analytics that can be performed on this data. And so this is how you know, I mean, our solution has been built, is to invite our customers to develop even themselves additional algorithm, additional analytics that would in the end create a community that would benefit to each of the stakeholders. Next slide. So as a conclusion, from this very inconvenient way of measuring the noise, we are now benefiting, thanks to the Internet of Things, of a completely revolutionary way to do it. So it is high accuracy, with high accuracy, it is with very low maintenance, it is low cost, and it is real time. But most important, what has been developed is actually for our customer, but together with our customers. Should it be the services of the pollution in the canton of Geneva, the SABRA, or should it be Chevron in the US? So, Anne, this is the end of my presentation, and I'll let you introduce the use cases and how, with Geneva, we have developed this solution. Thank you.
Thank you, Didier. Thank you for explaining more about the product. So effectively, we have invited today 2 of Orbiwise's customers to start with to explain to us use cases of sensors that have been deployed in the field. So we'll start off with a city use case. Paul, would you like to explain us more about what you guys have been doing in the city of Carouge and what is going to be coming in the city of Geneva?
Sure, thank you. Hello, everyone. Today I will speak on behalf of SABRA, which is part of the Cantonal Office for the Environment of the state of Geneva. The Canton of Geneva represents a total area of around 280 square kilometers, with a total population of around 500,000 inhabitants. 1/4 of it is exposed to excessive noise, mostly coming from around 300 kilometers of roads that need soundproofing measures. So the missions of our organization, the SABRA, regarding road traffic noise, they are the following. So first of all, we have to enforce the cantonal and federal legislations for the environmental protection against noise. Second, they are to monitor the road traffic noise pollution. Third, we have the task to produce noise maps to inform citizens. And finally, we are involved with noise mitigation plans in collaboration with other state organizations like civil engineering teams. And our task is to identify, to establish, and to implement and to maintain these plans. So the purpose of my presentation today is to talk about how we are using the noise sensor technology developed by Orbiwise to support the activities I just described. So if we could go to the next slide, please. So what is basically the problem we wanted to solve? So what you can see on this slide is a 2D noise map of the Canton of Geneva. To create this map, we used a numerical software that was taking into account measurement data that we collected by doing manual measurements using sound level meters, as it was previously explained by Didier. The issue with this approach is that first, it takes a lot of time to characterize the road traffic noise on a large scale territory. So for instance, for the Canton of Geneva, it typically takes us around 5 years to measure all the main roads for our canton and to update the noise map. Second, the measurement accuracy is also questionable because also we use a very precise instrument. It's a class 1 sound level meter. We only sample just a few minutes of noise out of a total day. And as you know, the noise level varies over time, by day, by week, and also over the years as the traffic evolves. And third issue that we have is that we cannot see how the noise is changing over a time period which is short. So to overcome these limitations, next slide, please. We decided to launch a project with Orbiwise and to tackle the following challenges. So the first thing is that we wanted to work with a low-cost noise sensor. And at that time, it was back in 2016, there was no out-of-the-shelf product which was available on the market for doing what we wanted to do. So the second point was we wanted to add some connectivity capabilities to use them within an IoT network. Third challenge was to produce batches of hundreds of sensors. We were not really interested in testing like just a few prototypes. We wanted to really test on large scale and to deploy the sensors in a city. And then we wanted, of course, to test the capabilities of the system and to use the data to integrate them to our noise maps. So if you could go to the next slide, please. So for this purpose, we submitted the project to the Swiss Confederation that granted us financial support to design, produce, and test this new type of sensors that we wanted to have. So you can see the outcome of this project on the first picture on the left of this slide. which shows how the sensor looks like. The second picture shows the casing of a sensor, which is open, and you can see the battery, which allows an autonomy of typically 1 to 2 years, depending on how the device is configured. The sensor was fully tested in the labs of the Federal Office of Metrology, as you can see on the third picture. And we found that also this type of device does not fully meet the requirements of a Class 1 sound level meter. The accuracy is well suited for the road traffic noise measurements we wanted to do. Just as a reference, the accuracy that we measured was within plus minus 0.5 dB compared to a Class 1 sound meter, which is very good for this type of application. If you go to the next slide, please. So this slide represents on the map the position of around 600 sensors that we deployed within the city of Carouge, which is one of the 45 municipalities of the canton of Geneva, and which was partner for this project. The total area which is covered is around 1 square kilometer. The spacing between each sensor was around 30 meters. The spacing was pretty short, pretty small, because we wanted to get enough redundancy to draw some conclusions on how many sensors need to be deployed to properly characterize a road section. So that means in the real life, we don't need to put that many sensors per meter. The next slide shows an example of how the sensors that are positioned in the real life. So in this case, the sensor is attached to a light pole. And the experience showed that we could let the sensor run for more than 1 year without having to change the battery. And we also came to the conclusion that the LoRa network works very well and was very reliable as far as communication process is concerned. The next slide shows another achievement from the Sabra within this project, which was the development of a software tool to visualize and to process the very large amount of data which were collected through the network of sensors. So once this work was done, we asked Orbywise to use our work and to develop a full and professional web application. And you can see on this slide the interface of this, what is called a noise app. And you can find several tools in this noise app which are very helpful to visualize various noise parameters, but you also have like noise indicators and tools to make some statistics. Next slide, please. So from a formal standpoint, this project was finished last year. It lasts around 5 years. And the table, which is shown on this slide, shows a list of lessons that we learned from this project. So first, we demonstrate that these sensors, they were providing a very good precision. Also, they were not fully meeting the requirements of the Class 1 sound level meter. We believe that meeting the full Class 1 requirements may not be absolutely required if we want to use this device for road traffic noise monitoring purposes. We also believe that some work may be done to define a new class of devices, having some indicative measurement capabilities, a little bit in the same spirit as what is done with the air sensor in the European Union. Second, we showed that these sensors, they were easy to install and to maintain. However, we also saw that it was important to position them very carefully. Otherwise, we may end up measuring different sources of noise. So some further improvements may be done to make these sensors more selective as far as the noise source is concerned. The third point is that we were able to get access to real-time measurements. So each of the 600 sensors which I presented you before, they were emitting measurements data every 15 minutes for more than 1 year, which is an enormous amount of data to process compared to what we normally do with standard sound level meters. And some work is still ongoing to develop some data processing tools to cope with all this amount of data. In addition, we could also get more than 1 year of measurements. And we also think it's possible to improve the autonomy of the sensor which could also make our life easier, because that means we don't need to go to the field and to replace the battery of the 600 sensors too often. And finally, thanks to the very large amount of data that we could extract from these measurements, we found it was quite easy to update our noise maps on the territory where these sensors they were deployed. And we believe that we can further develop the automation of this process and extend it to the complete territory of the state of Geneva. So the next slide shows the conclusions of this work. So what we can say is that Sabra has now access to a complete solution, including not only high performances and low-cost sensor, but also a reliable communication LoRa network, plus data storage platform, plus an application software allowing us to visualize and to process the data. And that's a complete package, which is very valuable for an organization like ours. So we intend to actively use this technology in the future. And for instance, we are currently deploying 200 devices within the city of Geneva right now with the purpose of monitoring the road traffic noise over the next year. So I'd like to finish this presentation and thank you for your attention.
Thank you, Paul. This gave a very good first impression of work that has been done in the field. So if there are questions for Paul or any of our other speakers, please feel free to drop those in the Q&A section. So we're going to move on to our last presentation of today. Sam Bisram, you are up next. So Sam is going to talk to us about a similar deployment, but for a totally different industry in the refinery of Chevron in California. So Sam, take it away.
Hello, everyone. As Anne mentioned, I'm Sam. I work for Chevron in our refinery in El Segundo, California, in the US. So next slide, Anne.
Yep.
So the El Segundo refinery is probably the only refinery in the world that's located uniquely sandwiched between two very affluent communities to the north. That's the city of El Segundo, and then another community on the south and the southwest, the city of Manhattan Beach. You might be wondering, why did Chevron decide to build a refinery right in the middle of a densely populated area next to some pristine shoreline? The refinery's been here for about 110 years, and those communities were not there when we built the refinery in the very early part of the 19th century. Those communities over time built up around the refinery, and so here we are. Within, as you can see from the map and the picture on the lower part of the screen, the refinery is approximately 1 square mile. There's residences literally a couple hundred feet away from our fence line. We have the LAX, or Los Angeles International Airport, which is about a mile to the north. Major highways all around the facility. And so our residents, because we are the largest industrial complex in the area, whenever there's noise, the assumption is that it's coming from the refinery. Our industry is not necessarily a favorable industry in modern times. And so we go to, lengthy steps to make sure that we're not affecting those communities that we operate. And again, this is a very sensitive neighborhoods, both north, south, east, west of the facility. There are other industries in the area, other power plants, aerospace and those kind of things. And when we want, whenever there's a noise complaint and we want to really try to engage with the community, we don't have a lot of data today. Go to the next slide, Anne. So what we had initially was a system that was about 40 years old, consisting of about 6 sensors, 3 of which were not working. It was installed by a very small company. The owners, which have retired since, 3 of the sensors are no longer working. And so we were looking for a new solution. The traditional way of doing something would be installing a electrical and instrumentation infrastructure throughout the refinery. to allow for comprehensive noise coverage. Next slide. So why Orby-wise? As I just mentioned, covering the entire refinery 1 square mile with a series of noise sensors so that we can understand if there's noise coming from the refinery that's impacting our neighbors would have been a very cost-effective and, a very costly endeavor, a very large project. Just the electrical infrastructure, conduits, wiring, the engineering work, and it would probably take a number of years to get that completed. We started down that path initially and then heard about Orby-wise. And after initially looking at it, we decided, hey, let's just pivot onto a small POC, what I would call a proof of concept. It seemed like it was very doable. The system was very expandable, very easy to install. The other thing that I really like is that if we have the initial system installed, which we do now, and we decide that there's other sensors that are needed anywhere else in the facility, in a matter of minutes, we can install a sensor. And everything is wireless. Next slide, Ann. So as I mentioned, we started with a small proof of concept in probably in the most sensitive part of the refinery. That's where we typically get all of our noise complaints, and that worked out very well. The sensors provided the data that we needed so that when we get those noise complaints in the community, we can actually go out to the community and have some real data to engage our neighbors with and actually present and show them, hey, this is what our noise profile looks like. Here's where we're not seeing any changes above our baseline noise levels. It's very likely something external to the refinery, the airport, the highways, allowed vehicles, some construction work external to the refinery. That was impossible for us to do prior to installing this system. Phase 2, we actually then went ahead and deployed a number of sensors throughout the facility. So where we pretty much blanketed the entire facility with noise sensors that we can then monitor, provide a real-time alerts back to our plant operations people, telling us that, hey, in some specific process unit, we have some elevated noise level that could potentially impact our neighbors. And so then we can take a proactive response. We're not waiting for our neighbors to complain that there's noise that they are hearing. And it might be coming from us. We can actually now monitor the entire facility and take a proactive measures to mitigate any noise that may impact the community. Phase 3 is where we're at right now. We're actually working on some advanced analytics that'll help us triangulate noise sources. So if there is increased noise coming from the refinery, we'll be able to, based on the number of sensors that we have installed, we'll be able to triangulate and actually understand exactly where that's coming from. So we can send our response people out and actually resolve those kind of issues. Things like weather, time of day, all those things affect noise levels. The ambient noise in the neighborhoods, those are all going to be part of our phase 3 enhancements. Next slide. I think this might be my last one. This is what the dashboard currently looks like. So the lower left is the that square on the lower left of the screen is the refinery. Okay, you can see all the sensors that we have installed. And in fact, this is a little bit of an older slide. We just recently now covered the very north side of the refinery with a number of sensors. So we now have comprehensive noise profile of the facility and can really understand if noise coming from the refinery could potentially impact any of our neighbors to the north, south, or east. Okay, next. Yes, that was my last slide.
So that brings us to questions and comments. Thank you, Sam, for your presentation. So this brings us to the final part of this webinar, a Q&A. So a few questions have come in, so I took a couple notes. Let me just start off with Theo, since you were up first. Theo, a question with respect to all of the changes that Europe is implementing currently. So the person is wondering what will happen to the transport and logistics sector and to commuting. How are people responding to measures that could be taken, for instance, with respect to reducing traffic, as you explained in your presentation? Do you have any insights on that?
And it's especially from the transport section.
I believe so. Yeah, transport and logistics, with respect to commuting, when so people going to their office. I believe. What is the impact there, and how does society respond to that? Because in some cases, people may not be happy with traffic reduction, right?
Yeah, because it's sometimes more complicated to reach your destination.
Exactly.
Yes, but yeah, as city, we have to make choices, and the healthy team is very important at the moment. So it's important that people can reach the city center, but there are other ways to come there with public transport, and maybe some garage and something like that next close to the city, so people can move by walking and cycling. Yeah, there are many ways, and the city will do some research. What's the best option, but it's important. Will you reduce the noise in the city? You better start and take action for a less traffic in the city. So, and yeah, we do some measures also with quiet roads, and so we do our best, but the best solution is quieter transport vehicles and other ways to travel.
Fair enough. Thank you. Thank you for replying to that. Paul, a few questions for you. One very obvious question that probably will come back many times is, what are the cost implications for your city? So can you give any insights as to the pricing that you underwent, and the budget that your city needed to spend on implementing this solution? And perhaps DJ wants to comment as well on the pricing situation, right?
Yeah, I will not give precise numbers, obviously, but for sure it's 1 to 2 orders of magnitude cheaper than the sound level meter, the sensor itself. Then I will maybe pass on DDLL to give some ballpark numbers about how much it costs. So what you need to take into account is that we do not only buy sensors. We buy sensors, but we also have to have like the right people to deploy the sensors. So that means you need to have a staff, a local team, which is able to do the maintenance. And then there are also some costs which are related to having access to the dashboard, and also the cost related to the network as well. So that's a complete package. So I think that's all I can say at this stage.
Yeah, thank you. DJ, is there anything you wanted to add on pricing, perhaps where people can find information on pricing, how they can purchase this solution?
Yeah, sure. I mean, we have, I mean, of course, I mean, they can go on our website and, just like request some quotations for this system. But at least, I mean, to give you an order of magnitude, the cheapest class 1 sound level meter that we see on the market are above 2,500 euro, and we are 10 times cheaper than that. And so the most important also to understand is that it is just not a question of simply one instrument. It's like passing from a situation, going from a situation where you have a map every 5 years to a map every 5 minutes. And that is, achieved at a much lower cost than what was spent until now by the cities or the industry to obtain this.
All right, I just gave a reference to the website where people can find more information on the noise solution as well and can contact you for further reference. Paul, one other question for you. Most cities make sound maps based on noise calculations or based on a traffic model instead of noise measurements. Does the city of Geneva have experience with both methods? And what is the experience in this case?
Yes, actually, the approach of the canton of Geneva was to combine both methods. So we use numerical simulations and we feed them with some input parameters related to the how many cars they are, traveling per each on each sections of roads, like speed limits and so on. And based on that, then we calculate the noise level on all the buildings. In parallel, we do these noise measurements, which were described by Didier Lal in his publication. And then we use these measurements to compare them with what we calculate. And then there is like an iteration where we have to adjust sometimes the input parameters of our simulations, such that we can match the measurements. So it's a combination of both approach that we are using. We are not only doing calculations or only doing measurements. It's a combination of both, actually. And the fact that we have a lot of sensors now, that makes it much easier because, first of all, the data, the measurement data that we can use, we have them on a lot of points at the same time. So we are sure that they represent the reality and not a noise level which was measured in 2020 and the next point was measured in 2018, then we are not sure that maybe this is exactly the same conditions. So I think that's a big advantage that we see.
All right, great, thank you. Sam, a question for you came in as well. How many of the sample sensors were needed to cover the entire area of the refinery? First of all, and second of all, in the surrounding neighborhoods, and how far do you get outside of the refinery? And so how long did it take you to get the entire system to be operational and to receive data results? You're on mute, Sam.
Sure. Yeah, so we currently have approximately 40 sensors installed in the facility, and then we have 2 sensors in the neighborhoods. Now, we plan to scale into the city, but we're waiting for the city to tell us. We don't want to just actually install. Our neighbors can be quite sensitive and not understand necessarily that these things are noise sensors. They can be suspicious that it's something else, some kind of spying device and all those kind of things. So we have to be very careful about installing devices out in the city without actually having the city give us permission to do that. But we have, as part of our community relations, we have a monthly meeting with our city leaders, and so we brought that up to them. They're very excited, and so we'll leave it up to them as far as how many more sensors they want installed in those surrounding areas. As far as how long it took, it actually installing the sensors and getting them running doesn't take long at all. To be honest, you could do that in a couple of days. It's just a matter of a few minutes actually to just place these sensors where you want. The work to make sure that you have these in the right location and the dashboard and the IT kind of things that you have to work in the background, that's what takes a little bit longer. And that's typically more on the customer side. In my case, Chevron, we have to make sure anything that we install complies with all of our cybersecurity kind of items and those kind of things. So that's the part that takes a little bit longer, but the actual system itself out of the box can be installed very, very quickly.
Great. Another question with respect to future developments of other refineries that Chevron has in mind. Is there anything you can tell us about that?
Sure. So as I mentioned, El Segundo is very unique in that we're probably the only refinery in the world where we're actually sandwiched in between some very densely populated, very affluent neighborhoods. Most of our refineries are not necessarily like that, but we do have our refinery to the north in the San Francisco Bay Area, our Richmond refinery. Parts of that refinery can affect the community, and we are looking at installing this system, not the entire complex, but a part of that facility. We have other petrochemical units throughout the world, and they are all aware of this solution and are awaiting their own evaluations as far as whether they're going to need something like this. Maybe not all of, again, not all of the facility, but certainly portions of those facilities where they're closer to neighborhoods that are next door.
All right. Okay, brilliant. Thank you. Didier, I think some questions for you because they're more of generic or on the related to the product. A question with respect to the security of your data storage. You were mentioning before effectively how data is being treated in the by the server in the cloud. So how does security work with respect to this?
So in many cases, this solution is proposed in software as a service. So our customer would deploy the sensors, and the data would come through our servers and be delivered to their servers. So what is important is that we are hosting today on Amazon. And so we are going through all the security audits of our customers, should they be like an individual customer with a few sensors, or big companies who are big multinational companies who have like very stringent security. So the security is clearly ensured also on the fact that the sensor is not recording any sound, it's just recording statistics of the noise, sending these statistics to the network, and these statistics are stored in the databases. So this is what is then provided to the customers.
Okay, thank you. Another question with respect to the quality of the sensor. So once, I think it was Paul who showed the image of having the sensor up and running, right, in real life. So with respect to exposure to wind, rain, heat, any external condition, how does the sensor react to that is the question.
So, I mean, I think that acousticians are much more knowledgeable than me in this topic, but what we have been discussing with them is that most of the time the wind is causing an issue to measure the noise. Should it be with a class 1 sound level meter or with our device? So we are actually having the same issues. So when there is wind up to a certain speed of wind, when there is rain, and so this usually is treated by the acousticians purely simply by discarding the data when there is, this inconvenience of wind or rain. So we are not more sensitive or less sensitive than any other device. It is just that we are suffering the issue as the same as any sound level.
Perfect, thank you. All right, I'm looking at the time, and I think we're coming to the top of the hour. There's a few more questions, but we won't have time today to answer them all. Please visit the OrbiWise website, orbywise.com, for more information. And if you want to get in touch there's a contact form where you can enter more questions. Also on the if you navigate to the samples part of the webpage, both Paul's and Sam's stories about the deployments in Carouge, Geneva, and at the refinery are there, so you can find more background information, as well as a brochure on the sample solution. So I would like to thank you all, guys, for your great presentations today. Very insightful. I hope to be able to welcome you in the future again. And thank you to the audience. The webinar will be published on the YouTube channel and website as well for review. So thank you, and then have a great day.
Thank you, and enjoy.
Bye-bye.
Bye-bye.